to let you know, guys, that again, this will be recorded, so try not to have your video on and stuff like that. If you have questions during the workshop, you certainly can type in the chat, but most likely I would not be able to see it because I have a lot of programs open. But I will be here in my personal room right after this workshop, all the way from 4:40 to 6 for an office hour. So if you have questions and if I couldn't see it in the chat, do write it down and ask me after. So for this workshop, we will first cover how to write a checking account. And then second, we will go over writing some functions to do a program for cryptocurrency comparisons. Not sure if you guys have the Google Drive folder that I use for all the workshop materials. All of the files has been uploaded there. Again, I will be sending out the links after the workshop. So if you don't have it, don't worry about it. And in terms of the data, I also upload the data for two cryptocurrencies, Bitcoin and Ethereum. They might be outdated, so feel free to update your own data and run through the program. So let's start with building a checking account. Another thing is that I do, for my workshop, I do tend to type along the way. So I do highly recommend you to have your Python shell or IDE open to type along with me. So I believe that's a better way to learn and practice. So Python is an object-oriented programming language, and almost everything in Python is an object with its properties and methods. A class is like an object constructor or a blueprint for creating objects. And here let's make a checking account. So here all classes have a function called init. I'll write it down. So this function means it is always executed when the class is being initiated, and use the init function to assign values to object properties or other operations that are necessarily to do when the object is being created. The init function is called automatically, it's being called automatically every time when the class is being used or create a new object. So let's create a class called checking and start with the initial function. And we want a variable called amount. One perks about the IDEs, the one I use is PyCharm, so sometimes it sort of autofill your functions. And if you're just typing in shell, you need to finish type yourself. So we start with once the user entered the program, you have opened a checking account with, and here is the amount that you want to deposit in. And then we have a balance. Our balance equals to the amount, the initiate amount that you deposit in your account. And this is called creating an instant variable. And the instant variable is variables that only count for one object that you created. We call it self as we don't have a variable name. So this self.balance is the process of creating an instance variable. And then we use a method called getter and setter method. So we want to first define a function. So define another function called get balance. And then we return self. So this allows you to see how much money we have in our checking account. And we create another function called deposit, which allows users to deposit certain amount in their checking account. And we return. So every time we deposit amount, we need to add the amount that we deposit into our system. So amount is the variable that we created in our first function, where the user started with the certain amount of deposit. So the balance is what we have in our account. And then the balance at amount is how much we deposit. And we want to notify the user, print you have deposit certain amount. Sorry, I forgot to put amount here too, because it's a different amount that we deposit every time. So it's also a variable in this function. And we also want to notify the user how much you have left. So your new balance is, and this time we print out the balance. Which self.balance would add the amount that we deposited. So here would be, there's no dot over here. Okay. So those are two different data types. So don't forget the comma. And other than deposit, we would also want an option to allow us to withdraw from our bank account. So we define another function called withdraw. So again, started with an instant variable for self, and then again we have another variable called amount. It's the amount that we withdraw every time. And so under the withdraw function, we want the program to determine that if we can withdraw the amount that's larger than what we have in our banking account. So in order to meet this, we need an if-else determination process to check our balance against the amount that we want to withdraw. So if amount we want to withdraw is larger than self dot balance, then we print we let the user know, hey, you have insufficient found, print, and we want to tell the user how much money you have left, print balance. And self.balance. And now if we want to withdraw the amount that's within, that's not more than what we have, so the system would allow user to withdraw. So the self.balance, which is a contradictory to what we have of deposit, we use minus equals. So we minus the amount that we withdraw and print you have withdrawn that amount and print. We want to print, let user know how much money you have left. Balance. Excuse me. Okay, so here is very basic steps of a checking account. And now after we've done this, we want to do a test to test if this program is working. So let's create an account called My Account. And we started with the checking. We can start with the checking of $300 in it. Not a lot of money, but so now print. We want to see how much money we have in our account. So we print my account balance, and then let's run it. I think. Oh, sorry. This is I ran the wrong project. This one is called class exercise. Okay. Init object is not callable. Let's see what problems we have. Command run. We get an error saying that integer object is not callable. My account checking. Class checking. My account it's the name is not balance, it's called get balance. So we change this to get balance. And we run it again. Okay, it's working now. So we started with the initial account, the initial function called print. You have opened the checking account with $300. And then we deposit $500 into our checkings account. And now we call our deposit function 500. Oops, sorry. So we deposit 500, and then we can let's take the blueprint, and now we can create as many objects as we want. So we create Bob's account. So Bob is rich. He has 1,000 or whatever, or $10,000, and then print. Let's print my account dot get balance, and then we want to type Bob's account, print Bob's account, get balance. Let's see what we have here. So here we see after we deposit $500, it shows as you have deposit $500 and the new balance is 800, which added together to the opening of the checking account. And here we get the two initial balance of get account of both my account and Bob's account, so it will return 800 and 1,000. So here now let's test our withdraw function. So as we have $800 in account, we want to withdraw 900. And then let's run and see what would happen. Let's ignore this line. So now we see that the system would notify us, call it saying insufficient found with a balance of 800. And if we withdraw 700, and here it let us do so, and then we have a new balance of $100. So before we move on to our next session, I will give you guys about 5 minutes to test out and run your own project, and try maybe withdraw from Bob's account or deposit to Bob's account or create your own account, and see if there's any problems. And let me see. How to type the init. You need to type an underline. So it's shift and then the key of underline, and then 2 underlines, and then init. And I will give you guys till 3:25 to just play with your own program. And if you have any question, let me know. And then we'll move on to our next session. Yeah, on self creating, it's basically so self, it refers to the variable itself, right? So it's basically called creating an instance variable, which variables that only counts for one object that you created. And we call it self as we don't have a variable name. So we see inside our, yeah, self is a variable. Okay, let's move on to the next session. So I will share a link in the chat. So in case you don't have access to that Drive, Google Drive folder, I just shared the link in the chat. So that would take you to a folder called Workshop 5. And inside Workshop 5, we see that there is a file called Pi2 data files, one called bitcondata.csv, one called asrmdata.csv. So I'll explain too. So this project is basically a comparison system that allows users to see the historical price and the trading flows of cryptocurrency. And also it would return the histogram of two different cryptocurrencies, Ethereum and Bitcoin. So we used those two because cryptocurrency is a relatively new concept. As Ethereum, we only have about 5 years old till now, and Bitcoin is about like 8 to 10 years old. So again, this data, if you look at it, it's a relatively, because I haven't updated the data file. I think it end at it's till like 2018 or something. So when you do your own project, feel free to like extend the data set with the updated data. So first we create a data file. Let me go to PyCharm, go back to PyCharm. And since everything is here, I'll create a new folder. 1 second. Let's do cryptocurrency crypto in class project. Okay, so here let's feel free to download those two data files from the folder, and I'll upload those two to GitHub too, so you can just import. I will share my browser with you too. 1 sec, Safari. So yeah, so I will upload those two files into the cryptocurrency, so we don't have to import from our own local directory. We can just import the data file to Python through a link. So 1 second. Let's add file, upload files. Let's see, where are those? I think they're saved over here. Okay, those two are data files. So in this folder, we don't need that. Okay, so I've uploaded those two to my directory, and I will share this directory with you. Paste it in the chat. And now let's start with creating a project to import data first. I'll stop sharing Sapphire so you don't get confused. Under crypto file, create new file. So in case, again, this is a relatively large program, and in case we're not able to finish what we want to do, go through the entire project during our class, feel free to go to the folder. It already uploaded all the code in there. So feel free to go back and take a look later. So let's create a library called data. So here is input data file. So to deal with CSV file, we use pandas. PD. We can import. So I would, in my code, I imported data frame and read CSV, but I think we don't need to have that step. Let me try again. So we have file one. So we import it. Called Python bit data. Oops, let me get the data. And file two. Let me import that as well. As data. So make sure keep in mind when you import data from a GitHub, make sure that when you copy the link, do not use copy directly from the data surface on the GitHub page. You click the raw, and then it will take you to a raw data page, and then import data from there. And now we have the data, and then pd.read CSV dot file one. So when you are doing it on your end, you don't have to do this file one steps. You can simply paste the link to the data over here. I purely did this to make sure you guys it's clear for you guys to see. But when you are doing it yourself, you don't have to do that. We skip the rows because the first row is the names. And we have a column, the left column is called date. So we want the program to know that the first column of our data set is date as data. Now let's run this. Let's see what error we have. Oh, okay, we have a significant error, so we need to add that into it. Give me 1 second. We have there's a package called SSH that allows us to go through the security of GitHub. Give me 1 second. Let me take a quick look. Yeah, so here, because we're importing from GitHub, so this is called secure socket C secure sockets. Do keep that code in your mind, because that gets rid of the error basically telling me that on the certificate verify failed is telling me that I can't access that data without logging to the GitHub. So the way we get away with it is we import that, and we add a line of code. It's SSL dot create default context. Default dot create unverified context. Okay. Now this should work. Okay, cool, great. So now it's working now. And let's see. Print. Great, so now we can see that our data file has been imported. We have 3 columns, date, price, and volume. We don't need those. So I will paste this line of code to you in the chat in case that you encountered the same issue. Okay. So we would just leave it as it is, called the data file, and then we will create a new 2 different programs. One is building some basic statistics that compares 2 different cryptocurrencies, and then we do another visualization file. Okay. So we file, new file. No. And we call it phase 1. Oh wait, before we calculate them, we need to do some basic cleaning for those 2 currencies. And before we go that, we'll create a Python file called currency. So here is, let's call it the library. It's a crypto keeper library, so we import numpy as np, import pandas as pd, import matplotlib .pyplot as plt, import matplotlib.ticker, as that allows us to deal with times. So so again, the name after as, you can call it whatever. You can call them 1B, A, B, C. It's just usually we call NumPy, NP, Pandas, PD. It's just a commonly used name, but it's random. It's just a variable. Matplot dates as dates import matplotlib. And now we import our data file that we just created that downloaded from GitHub. Yeah, cap, there is a cap. So now we first create a superclass called currency. And again, like our check-ins account, we started with the initial function, define in the init. And it comes with a self, and then here we want data. Self data. So here we define the self here as just the data. So we want this program, we want to look into those two current cryptocurrencies on a quarterly base. So we have self.data. We want to do 3 months. And we do self.data. Lock, the .lock function allows you to lock down the certain time period. Self.data. And when we look into the date is the date over here is different from import live date as date. The date refers to the column name date to tell the program to look into the column date. And we want the date to from between 2018, January 16th, and at the date at 2018, April 16th. So we want later than 2018. I need to go back to the data file to take a look at the formatter for the date. Okay. And we want it to end at self data date. That smaller equals to means earlier than 2018, April 16th. And we commented called 3 months data. And then we would have 6 months data. I would just copy paste it because I don't want to type from scratch. And here for 6 months, we want from earlier 2017. So I picked 16. It has nothing to do with like the starting of the quarter. I picked 16 just because the data file ended on 2018 January 16, I believe. Of now April 16. So again, once you update your data file, you can choose the date of today's date, which is October 2020. So I picked 3 months, 6 months, 12 months, and 24 months. It's basically letting the user to decide how long of the data they want to see, and then sometimes when making determinations, not want to look too far into it. Maybe users just not want to compare the past 3 months and make a forecast on that. And some users would prefer to have a longer historical data. So again, that's why I created those 4 frames. Okay. So, so we look back from 6 months, and as the ending date is always the 2018 April 16th. So it depends to let them see how long they want to see. So if you go download update the data file all the way till today, then it'd be 2020 October 6th, and we go back to 12 months and stuff like that. So if we go back to 12 months, that'd be 2017 April 16th from this data set. And here we want to go back to 2016. Okay. And then we can start with our functions. Another function, define get data. So we only set 4 options, so they can choose to get data by period. If period value. Same thing for 12 months and 24 months. So 24. Okay, so this allows users to decide how much of the how long of the historical data they want. I will give you guys 2 minutes to just look back into the data set and just look at the functions of the dates we have, and then we'll keep going from here. I'll be right back. Okay, I'm back. Let's keep going. Um, paste a link in the code. What do you mean paste a link? You mean the link of the code? Yeah, it's do you see the first drive.google link? That one has all the completed program code in it. So you guys should already have access to it. And we also want to allow users to get data by date. So we define get data. No, if you go above GitHub, there is a Google Drive link. I'll send again, S325. But if you sign up and then you type your email correct, then I will send another email at the end of this class. So with all the links included, so don't worry about it. Get data by date. We also want to allow users to type in their own date, starting date. I'll paste the link again. It's basically the same thing as what we had, but this gives users the flexibility to type in their own frame, the time frame they want to see. So data. Again, we want to lock down the date. So the date must be in the form of year, month, date, is to allow users to like search into our data form to match the column name on the date. That's why. So if you have a file that the date is in different format, so for example, it's like month, date, and year, then you should type in a different format of date. Okay, so here we want to see a frame that's later than their starting date, but earlier than their end date. Is earlier than any ending date. Okay. So that's about it for the date frame. And now we want to cover some statistical basics. So for example, we want to show the minimum price, the lowest price of all time. Then we define get minimum. So here, the .2f is just a formatting command as we want to see the two, sorry, not parentheses. It's a bit hard to type this. It's a formatting command to show the two decimals. And we want to show the minim. It would be the same for all other periods. Let me see if I can just go copy paste it. I'll copy this line of code so we don't have to type again every time. And then we get max. Oops, sorry. So we want to show the largest number of all the period. Return the same. Here, the difference is here would be the max. And then we also want to get average. Then we use mean over here. So again, the period over here refers to the our earlier variable that allows user to type in 3 months, 6 months, 12 or 24 months period. And then those few functions would basically get the minimum, maximum, and average of the indicated period. And then we want to get, let's see what else we can get, standard deviation. To get standard deviation, there is also a function called std that's already inbuilt. So those four is basically some basic stochastic summary of of those two price. So okay, so this is if you're still confused about this, it's basically just it has no programming meaning, as it's not a function or anything. It just basically tells the program to print only the first 2 digits after the decimal point. So here we want the program to print 2 decimal point. And if you want to only print the integer, or if you want to only show the 1 decimal point, you can do one not dot two. You can only do dot one. Okay, so now let's keep going. And now we want to display, we give the user the option to display the most current period. So the current period, the current price. So the most recent price we have is on April 15th, 2018. So we want to do current price. So we want to see what's the current price we have. So again, this data, as you may see, the problem is that this data is not real time. So if you want to create a program that allows you to show real-time data, feel free. We will cover another workshop in API, which allow our program to draw real-time automatic updated data from APIs. But right now we are just using a data set that we pre-downloaded. So we define current price. And for this one, we want to self.price. We don't need. Sorry, I got my Siri out. Let me turn it off. We still want 2 decimal point. After that, we want to also, one indicator is simple moving average. And to calculate the simple moving average, we need the percentage change. Calculate the percentage change in price. And then we want to do the latest compared to the earliest. So we call it price change. Oops, I keep forgetting that it already automatically linked to the self data. So again, we use period data over here. And then we have the old price. P refers to price over here. And then you can, if you want to type down the whole price, that's fine. In the end, it's just a variable name. Again, the price here refers to the name of the column, and then we have the new price. And then we want to do a change in price change. We want the function new price minus old price and divide old price, right? That's a percentage change. And return. Again, this is just a format tells you to return 2 decimal point. And okay, so that's a percentage change. So once we get the percentage change, then we can do the SMA, which is called simple moving average. I'll type the full name here. We'll just call it SMA. Again, we use period data. Get data. I think in Python, you don't necessarily need parentheses after if values. You can try that. I believe we don't, but depends. So this one is the same as we have for periods. So if you are confused about what is n, it's basically just an interval. So now we can defining Defining the interval for SMA graph. Okay, so that's a simple moving average interval and definition. Later, we'll calculate the percentage return based on the past 30 days info. Again, I'll pause for about a minute to just let you guys follow up with the code. And I'll be back in a minute or two. Oh, so I saw people ask what's the difference between .lock and .ilog. So lock is label based, which allows you to specify the name of the rows and columns based on like the labels, right? So their names. And ilog is an integer index based. So it allows you to locate the or specify the rows and columns by their integer index. That's a difference. So, for example, the ilog 0 refers to the very first column in our data set, or you can use log with the name of it. Yeah, the 2.f, it's basically telling you that the dollar sign it just a formatting. It tells you the program to print out the two decimals after the number, because for the cryptocurrencies we have, it's like for example would be 5.3678 blah blah blah. We round it to two decimals. That's what it means. Yes, correct. And yes, and if you want to do 0.1, then that's dot 1. And if you want to do 0.001, then that's dot 3. Okay, we can keep going. So, one thing is F refers to, it's not for format, it refers to the data types. So here, remember, for every data we have a decimal, it's not an integer. The data type is called float, and that's what it refers to. Let's see if we displayed the current players already. Okay, we already did that. Yeah, float. Float is a data type. So integer is like 1, 2, 3, 4. Float is like 1.2, 1.3. Everything with a decimal point is a float. If for example, if it's 5.0, it's still a float. But if it's just a 5, that's an integer. That's a data type. And we want now to calculate project percentage return based on the past 30 days information. So the project change is projected change. Again, if you don't like this variable name, you can name it whatever, or if you want to type down the whole thing, that's fine too. – 16, the data set ended 16. So here is, as we want to calculate the projected percentage returns for the past months, so we went back to a month from the ending data for our data set. We called it, what's the name of it? Percentage change. I'll explain it after I typed it down. So I'll explain this function. So C is the that one is pretty obvious. Is that we is how we get the geometric mean of percentage change, and D is the D is we convert NumPy float to float, and so B is that we set a range of 1 to 7 as date. So every time we append one number into B, and then we calculate the geometric mean of percentage change of each B. And that's how we do the projected percentage return. So that's based on, for the projected percentage return, C is basically based on the function of that definition of the projected percentage return. Let me see if I'll type down the original format for the projected percentage return. It's also called the expected return. So expected return. It's a sum of so this one is just a definition where I here indicates each known return and its respective probability in the series. So again, it's expected, so it's usually based on the historical data we have. Again, this is just a economic definition. Again, we don't have to pay too much attention to it if you want in the future using a different model, a different function to it. So now we quickly, let's see if we have time to do a histogram. Define hist, then self dot period. Starting with the price data. So dot get data. Here I just simply use the get data period. You can do the get data by date as well. I used get period just to make it simple. So here column equals to price is another syntax. It's another way to locate the current a column with the name price under. So here is the syntax of the Matplotlib. Y label, we call it frequency. And then we plot show. So if we run it right now, it will probably not show because we haven't called the function yet. But what if you go to the finished, the completed code, and you see in the end we were able to call the function. So then the program would generate you a histogram of price and then later volume. And let's go back. Exact returns. We also do log returns. We still have 1 minute. Let's quickly calculate the log return, which is another commonly used definition, concept to calculate returns. When I place log return before the histogram. Dot get data, we still do a period just to make it easy. And df, it's a variable, it's a called data file. Data file price is another way to refer to the price column in our data file. So that's a pandas index, a pandas syntax. Here we use numpy.log. So as you may notice, each library like pandas, numpy, or matplotlib, their syntax varies a little bit. Do pay attention to that. So we want to compare price to price. Okay, so that's a function to log return. The log return, again, the log return function is np.log, and np, as we stated earlier, it refers to the numpy syntax. So here, the log return is an inbuilt function for numpy. So again, we don't have time to cover the entire project as we still have like a few more other functions in there. Feel free to go to the folder and look into the whole project and run it yourself. And if you have any questions, feel free to shoot me an email, and I'll be in my personal room till 6. And so for the function I just covered, so the in place, I think I'll quickly go over the both in place true and in place false. So our data operations. So in place true, it performs the operation on data. Basically, nothing is returned. And in place equals false, it basically performs operation on data and returns a new copy of data. So here we used in place true, basically saying that we do not want to have a new copy of data. So if plus equals that's something we covered in the very, very first workshop. That's plus equals means every time you run the program, you add the variable. So it's a cumulative plus equals. For example, we have a plus equals 4, a plus equals 3. That means we add 3 every time to a. And a equals, we assign 5 to a, and a plus equals 3, and now we print a. This is a bad place to write it because I already had so many things printed. But if you're again, we have this covered in the first workshop. So it's basically a plus, but we add it every time. So sometimes in the program, if we want to add a variable, right? So let's say if we have inventory and then for a week and we have new inventory coming in every day. So instead of manually added by hand, we can just do inventory plus equals day 1, day 2, day 3. So we can add a more flexible variable to it. It just a plus something and equals. And the same thing as two plus sign. So it's basically means how do it's easier if I just run it, but as we again in this program we have so many things in this already, so it's a time. Okay, I'll go to a blank page and then show you. Let me see if it's workshop 1 or workshop 2. Give me 1 second. In class note. Okay, so let's use this one. I'll get rid of this. Okay. A is like a times b is basically a not square root, but so if a is 10, b is 2. So if I have a command a times b, I've got a term for that. So that basically means 10, the square of 10. And if b is 3, it means the square, the triple square of 10. I hope that's clear. So if we do that, we print. So this, if we print a times b, that will show you 100. What's it's called in class node py. See, it will show you 100. And if b is 3, it will show you 1000. I hope it's this one's more straightforward. So it's on the term, it's on what's the term again? Exponential operator, I believe. Okay, great. Yeah. Sorry, it's on this one's easy. If again, I have video recordings for previous 2 workshops that covers all the basic data types. It seems that you missed that. So this is an integer, and if we have float as decimal points, and we have data types like string, array, list, tuple, stuff like that, all covered in the very, very beginning of the workshop. So feel free to go back and review it. And I'll send you an email of the recordings and then the previous workshops as well. And if you have more questions, feel free to drop into my office hours or send an email to schedule an office hour. And others who doesn't have questions, feel free to. It's the workshop is over now, so feel free to leave. Yep, thank you, you too.